11, start us off. Circumference formula.
Pi times diameter.
Pi d. And that letter D stands for, in a circle, 17? Diameter length. Good. No issues there. I'm going to add on another formula today by the end of class. Let's go vocabulary now. This is circle Z. I'll stop right there. Forget about my other questions. If that's circle Z, what do you already know? 27? That's got to be point Z. Yep. Circle named by its center. All right, let's go to the vocab now. Just don't come on up here. I don't want you near me. Describe how you would draw in radius ZA, please. Radius ZA. Radius. Describe to me how should I draw this? 27. I already heard from you. 18.
From the center point to the outside.
I'm being tough here.
To the end point on the center of the circle.
Somewhere on the circle. Okay, somewhere on the circle. Here you go. Here's a radius, ZA. Got to come from the center, though. Got to. How about diameter LP? Diameter LP, 11.
It's just 2 points on the circle that go through Z.
Got to go through the center. Right? LP. And I have to draw it through the center. It looks great. And how about chord QC? Chord QC. 17.
It's like a point from one side to the other side, but not going to the center.
Could it?
No. Yes. Sorry.
As long as the two endpoints are on the circle, a diameter is a chord, remember. A diameter is the chord. It's actually the longest chord in a circle. All right, chord endpoints are on the circle. Any questions there? Yes, more vocabulary today. Yes, one more theorem. One more formula, and I'm going to introduce your first theorem here. Any questions on the homework? Most of you finished it in class on Friday. Any issues with it? Circumference, that's what the homework covered, circumference, really. Anything? We're all good? Anybody not here on Friday? You got the packet already? How'd the homework go? You sure?
Yeah.
You got it for me?
Yeah.
All right. Just take a quick peek because I know the rest of these kids. All right. All good? You ready to get it going now? All right. You guys know the deal. Calculators needed every day somehow. Might not need them at first, but I'm sure we will eventually will. All right, let's do this. First vocabulary term right off the bat. So we got radius, we got diameter, we got chord, and now we have central angle. In a circle, I can draw multiple angles in a circle. All right, so let me just show you a bunch of angles that we're going to discuss through here. I could draw an angle that looks like that. I could draw an angle that's formed by two chords intersecting. See that angle right there? Good. Here's the one we're going to focus on today. It's called a central angle. What makes it central versus those other two I just threw up? The vertex is the center of the circle. So if your vertex of your angle is the center of the circle, and I'm just blowing this diagram up here, you have on your hands what's called a central angle. So in your diagram on your paper, I'd be referring to angle AOB as a central angle because the vertex is the center of the circle. If the vertex is somewhere else in the circle, not central. We'll call it something else later on down the road, but for today only, that's called a central angle. Next vocabulary term, an arc. An arc. That is a piece of the circle. Piece of the circle is called the arc. Let's talk about how to name it properly with the right notation. Everyone remembers way back in Unit 1, we did line segments, and it had a little notation for it, right? It had a symbol. We did lines, we did rays, all of it had little symbols. Arcs have symbols too, so let's make sure we write them correctly going forward. Arc. It's literally an arc. Underneath it, you have at least 2 letters telling me what arc you're talking about. So let me put these first 2 letters down. Arc AB. What am I talking about when I say arc AB? You go direct, you follow the order of the letters. A to B. Whoop, A to B. I'm talking about this arc. Right there. Couldn't I also be talking about this one? Okay, here's the thing though. Watch how I'm going to change my notation if I want the other one. Because you're right, 100% right. Are you talking about that one, arc A to B? Or I could go A to B going this way. Which one are you talking about? Well, if I wanted the bigger one, I'd put a little more detail in it. I'm going to call that one A, whoop, CB. You can have as many points underneath your arc as you need. Minimum of 2, though. So does everyone see the difference between those 2 arcs? Follow the order of the letters. A to C to B. That's the arc we're talking about. All right, so I just talked about a central angle and I talked about an arc. How many degrees in a circle? 360. So every arc here is a degree out of 360. So let's say, I don't know, what's this arc? How many degrees do you think this arc looks like out of 360? 70? Fine, I'm fine with that. I'm going to throw a 70 on there. Here's your first theorem of the unit. Whatever the arc measure is, it's the same as the central angle. So if I know that arc is 70 degrees, so is that central angle right there. So first theorem of the unit, measure of an arc is equal to the measure of its, what do we call that angle again? Central angle. They always go together. The central angle is 70, so will the arc. And remember, this just means 70 degrees out of 360. All right? We okay on that? All right. Whoa, more vocab. More vocab. 3 types of arcs I need you to be familiar with. A semicircle. That's half a circle. How many degrees do you think are in a semicircle? Buck 80, darn right. Half circle measures 180 degrees. If it measures more than 180, I call it a major arc. Major arc if it's more than 180. If it's smaller than a semicircle, I call it a minor arc. All right, so I need you to be familiar with those 3. Semicircle is a half circle. Anything more is major. Anything less, minor. All right, by yourself or in your groups right now, I have 3 diagrams. I want you to identify these 3 types of arcs. So in diagram number 1, I want you to identify a semicircle for me. Name it properly, please, with the correct notation we just went over. Diagram number 2, I want you to identify a minor arc for me in that diagram. And then finally, in number 3, identify a major arc. Please start using your notation. So go ahead. Got a little less than a minute here to identify those arcs. This is just getting used to writing it now, writing the correct notation for the arcs. Please don't spell arc. I'm not interested in that anymore. I want the notation. Oh, we're done? We're ready to go? All right, give me the name of a semicircle up here. 8, semicircle, go.
Arc TRS.
TRS, yep. You could have also said arc TS. That would have been a semicircle as well. I would have gone right from T to S, no stops in between. How about a minor arc for me up here? Minor arc, ho, 14, minor arc. RS. If you had SR, same thing. If anybody had TR or RT, I like it too. How about major arc then? A major arc, 23. RTS, like it a lot. Or STR. Cool. Here we go. Good. Any questions? All right, let's put some actual numbers now to it. Find the measure of each of these arcs in circle C. That's huge. How do you know C is the center? Because I called it circle C. All right, ready? AE. I'm going to start off with 1, and I'll let you do it 2 through 6 on your own and in your group. So arc AE. How many degrees are in arc AE? Well, we just learned a theorem. However many degrees in arc AE is the same as angle ACE, right? That's a central angle equal to its arc. How many degrees in ACE? 4. 90 degrees. So that means there's got to be 90 degrees in arc AE. All right, so go ahead within your group by yourself. Go ahead 2 through 6. Follow the order of the letters. Hey, what do you here go? Number ED, length of arc ED. Number 2 here. 5, what do you got for me? 50. DBA, arc DBA. Oh, 5. Oh, I haven't heard from Claire. Sorry. 16. 220. Yeah. Arc AED. We're rolling. 14. Buck 40. ABD. I don't know if anybody noticed this one. 20.
220.
220. Oh, it's just number 3 renamed backwards. Oh, I wish I saw that. 23. How about arc BD? 130. All right, everyone's good to go. Arc is equal to its central angle. Let me take the degrees away and let's put percents now. Your good old pie charts from elementary school. You still do those? You survey everyone and do the no, not anymore. All right, never mind. Good times. So I'm looking for arc AB. What's the measure in degrees of arc AB? Well, I don't know the degree measure, but I know it takes up 20% of this full circle. 20% of the full circle. What are you taking 20% of then if it's of the full circle? 4? 360. How do I take 20% of 360, by the way? It's easy to say, but how do I take relax over here? 7? How do I take 20% of 360? 0.8? That's 80%. 0.2, thank you. 360 times 0.2. Look at everybody typing like they're texting. 12, what did you get for arc AB? 70, 2 degrees, looks good. And then just so we make sure we got this, we're all solid here. CD, 18% of it. So times 0.18 now. And arc CD, 3, when you're ready. 64.8. Now you can go. All right, great. So there's half a class today. Are we okay on measure? How to find, when I ask for the measure of an arc, that's in degrees. How many degrees out of 360 does that arc represent? Now we're going to go another direction and say, how long is the arc actually? If I had you guys take a pair of scissors, cut it out, put it in front of a ruler, how long is it? Everyone, I want you to make sure before I throw this formula at you, you know the difference. What's the measure? I want to know how many degrees out of 360 it is. All right, how long it is, that's what we're about to find. All right, so two totally different things. Measure degrees, how long it is. Here's your second formula. The first one was circumference, if you remember. Ready for formula number 2. How long is an arc? Well, you do still have to find the measure of it, because that's how I'm going to start this formula. You take the measure of the arc, so in degrees, what we've just been finding, put it over 360. So you're telling me what part of this circle is your arc, and then you're going to multiply that by, and then this formula is going to look pretty familiar. Pi d. What was that a formula for? Circumference. So you see what's actually happening here in this formula? What fraction of the circumference do you have? That's your length of the arc. What fraction of the circumference? Remember, what was circumference again? That's my distance around the circle. So what part of the circle here do I have? All right, so there's formula number 2. Let's use it. Find the length of arc AB. And just so we're clear, I don't have any, what do you mean? I'm talking this arc here. I know I should put another letter on there. Arc AB right there. How long is it? Long. Don't tell me it's 90 degrees. That's the measure of it, which I just gave that away. So we're going to start out with 90 over 360 times diameter here. 16 diameter. 24 pi. Whoa, hopefully we're not going too ahead here. What's the directions? Same ones from Friday. Leave your answer. Terms of pi. Talk to me. What am I looking for then at the end of this? If it says in terms of pi. 10, talk to me here. What am I looking for? It's just like so. No. 19, what am I looking for here?
Like a number next to 5.
I need that pi brought in your answer. I don't need it pressed here on your calculator. All right, so I should see that pi in the answer. So watch. So let's bring it down the answer. Whatever's left, calculate it. 90 over 360 times 24. Just don't touch the pi. Just bring it down in your answer, because I don't want to round. I don't want long decimals. I just want a nice answer with pi in it. And what's with the pi here? 7? 6. All right, if you're really nuts and have no life and you want to really see how long it is, do 6 pi, and that's how long that arc is, of almost 19 inches. All right, so we're good. All right, next up, read the darn problem, please. I'm looking for the length of arc CDE. Follow the letters to identify the arc. C to D to E. I put 40 up there, but not to use it in the formula. You won't see a 40 pop up in my formula. You will use it, though, to find what is the arc measure of CDE. 11?
320.
320. 360 minus 40, good. And how about my diameter here to plug it into pi d? Oh, 23? 18. Pi. Leave the pi in your answer. Calculate everything else. Whew. And what do we get in terms of pi? When you're ready, 27. What do you have? 16 pi. Good. And again, you guys know I feel I'm not going to fight you on the units if you want to put them or not. And final one here together before I let you guys do the honors level problem at the end. FGH. Follow the order. F to G to H. How long is that one? All right, first, how about the measure of that arc? Measure in degrees. 19. $1.35 over 360 times pi. Diameter length. 11 again.
6.
6. Leave the pi in your answer. And in terms of pi, how long is that arc? 4. 2.25. Yes. If anybody left it as a fraction, that's fine too. Any issues here? All right, I'm going to leave the notes here today with an honors level problem that basically combines circumference from Friday with arc length right with today. And I'm not going to talk much about it. All right, I want to see what you guys in your group can come up with, you individually. First of all, what am I looking for? I want to make sure you go down the right path here. What are we looking for? Okay, stop there. That's a formula, which is what? I'm looking for, it says find the circumference. What's the formula I need? 26? And we talked on Friday, what's the only value you need to plug in? Diameter. So somehow you, by yourself, in your group, have to figure out what's the diameter length here. Let me keep pushing you down the right path. What's the 6.09 I have given you? What's the 6.09? 13, what's the 6.09 represent? Length of an arc, which I gave you a formula for today, which also has what value in it? The length of an arc formula has what value in it? Diameter. There you go. So I'm going to take 6.09, use it in my length of an arc formula to find D to plug it back into circumference. Go right ahead. See what you guys can do. Just talk it out. Let's start discussing this first. And a lot of people are doing this, and it happened last period too. The length from J to K, 6.09. I'm looking for the circumference, which is what? The distance around the entire circle. So I better make sure my answer is bigger than 6.09. Because this from here to here is 6.09. I'm looking for the whole thing here. So I should get an answer bigger than 6.09. So going to the arc length formula. 6.09 equals the measure, which is 50 degrees, the central angle, over 360 times pi d. Here's where we're going wrong is how do you solve that for d? Right? It's all multiplication. We shouldn't be subtracting something over. This is all multiplication. So if you guys want to get rid of 50 over 360, you're going to have to divide it out or multiply both sides by its reciprocal, 50 over 360. Okay, either one here. Just make that big. Okay, you can't subtract it over. It's all multiplication. And then after that, you divide your pi. Then we end up with, I don't have that diameter value, but you plug it back in, and we should end up with, oh, nope, sorry, 43.8 for the circumference. Whoa, I still got another honors level question here. Anybody going to tell me, or do you know that I did a couple extra steps I didn't need? I didn't need to go back here and plug it back in. Watch, well, hey, when I got rid of the 50 over 360, and that's wrong. Nobody's going to tell me that. When I get rid of the 50 over 360, ready? Gone. I multiply over that side. What's left on the right side? What's left on my right side? Pi d, which is another name for. So that would have told you already what you would have gotten here. Okay, so another, it didn't have to go all the way, but if you did, still 43.8. Are we all right solving? Are we all right here? All right, I'm going to forewarn everyone before I let you go to the assignment. You have number 59 tonight. Actually, why don't I just pull it up here? Because I'm not going to hear the whining tomorrow or people just quitting before you even start the problem. Where is it? I don't even have it up here anymore. Whoa, no. charts. Where is it? There it is. Okay, here's number 59. If you can't see it in the back, let me blow it up for you. Everyone see that word next to number 59? Challenge? It's not. It's a review problem. Okay, so just, challenge. I'm done. Good night. No. Baloney. All right, you're trying this one. It's not a challenge. Anybody remember back in the day what happens when I have numbers in a ratio? What should I put with them before I write an equation? Okay, you know how to do the problem already. All right, don't give me the challenge excuse tomorrow. Go ahead, get started. Coming over, Lee.